Hey guys, it's Miss X Storm. All right, we're back to do our proof. What we're going to do is we're going to prove the converse of the alternate interior angles theorem. So it's the alternate interior angles converse. So that means that we cannot use that theorem in our proof. All right, we're proving that. Okay, so let's get started here. We've got statements and we've got reasons, and you're going to need to hit pause just for a minute to get everything copied down. Okay. All right, so your given is that your lines are parallel. No, you're not given that they're parallel. You have lines L and M and a transversal T. So L and M and oh my goodness, could that be any messier? Transversal T. You also know that angle 3 is congruent to angle 6. Okay? And obviously the reason is given. Please don't miss that. Now you need to mark this given information. Angle 3 is congruent to angle 6. Now, hey, what does your brain tell you when you mark those angles? Your brain should tell you that those are alternate interior angles. But we are proving the converse of the alternate interior angles theorem, so we cannot use it. That's what we're proving. All right, now I'm going to walk you through this. Pay attention. This is actually one of the proofs in your notes when you read, okay? So be sure that you can do this. What we need to do is we need to use a different type of angle. And what we're going to use is, what type of angle did we learn that was congruent before we learned alternate interior angles? Because you have to do them in order. We learned corresponding angles first and then alternate interior angles. So the only thing you can use to prove this converse of the alternate interior angles is the corresponding angles converse. Okay, so we've got to get corresponding angles. Now there's a couple ways to do that. The way I'm going to do it is I'm going to use angle 6 and angle 2. Those are the angles that I want to be corresponding. Okay? Now, I can't just say they're congruent. I don't know they're congruent. But I do know that angle 3 and angle 2 are congruent. How do I know that? Well, let me back up just a second, because what kind of angles are angle 3 and angle 2? That's the first statement. Angle 3 and angle 2 are what kind of angles? Vertical angles. Okay, hopefully you can read that. Angle 3 and angle 2 are vertical angles. Now, how do you know that? Well, because they are. I can look at them and tell. Okay, so that's the definition of vertical angles. Okay, because they are vertical angles, because I can look at it and tell, so that's the definition. Now, what's the next thing you know? You know that angle 3 is congruent to angle 2 because all vertical angles are congruent, right? Now, I'm having a very difficult time writing. I've got something uploading in the background here, so that could be causing this problem. Sorry about that. Let me see if I can type, if that'll make it better. Okay, so what's the reason that angle 3 and angle 2 are congruent? There's two ways to say this. The actual theorem is the vertical angles theorem, okay? You can also say all vertical angles are congruent. Okay? Either way. Now let's go back and look at our picture. We've got angle 3 congruent to angle 2. We know that now. We know that 3 and 6 are congruent. So if 3 is congruent to 6 and 3 is also congruent to 2, then what do we know? We know that angle 6 is congruent to angle 2, right? Let me see if I can make this larger. So angle 6 is congruent to angle 2. Now, what's the reason? What's the reason? That's the transitive property of congruence here, because we're using the congruent symbol. Okay, remember, if A equals B, let me type it over here. If A equals B and B equals C, then A equals C. Remember that? That's the transitive property. That's all we've done here. 3 is congruent to 6, or if you want to read 6 is congruent to 3, and 3 is congruent to 2, then we know 6 is congruent to 2. That's all that is. Okay, the transitive property of congruence. Now what do we know? Let's go back and look at our picture. If 6 is congruent to 2, what kind of angles are those? Corresponding angles. So now do we know, remember that's what we're proving, do we know that our lines L and M are parallel? Yeah, we do. And I've ran out of room. Let me put number 5 up here. I ran out of room. This is statement 5. So L is parallel. Uh-oh, what happened? L is parallel to M. Let me go back and put a space in there. Shoot. Well, I can't. I have these automatic things that type when I type certain letters, and L is one of those letters. So L is parallel to M. Hopefully you can read that well enough there. And how do you know that? Because they're 2 and 6 are corresponding. So the corresponding angles converse. Okay, and there's your proof. That's what you were trying to prove. You're going to see something very similar to this on your test, so you should be able to do this. It's real important that you know this statement 3 here, that once you have vertical angles, you know that they're congruent because of the vertical angles theorem. Transitive property, and then obviously we're proving this, alternate interior angles, and we used corresponding angles to do that. Okay, so if you have alternate interior angles now, you just know that the lines are parallel because we just proved it. Okay, great. Be sure you can do this. If you need to go back and watch it again, you should do it again on your paper. Write your given, your proven, your picture, and do it again from scratch on your paper, and make sure you can do it by yourself. And then look back at your notes if you need to. All right, let me know if you have questions.